Mass is a common measure used across all sciences and has vast applications in everyday life. Mass is a measurement of the amount of matter an object has. The base unit of measurement for mass is grams, and the standard unit is the kilogram. The gram base unit is often used with the metric prefixes milli, as in milligrams, or kilo, as in kilograms. Mass is often confused with weight. Weight measures the force gravity exerts on the mass of an object. The base unit of force is a newton. For example, if you have a mass of 60 kilograms standing on Earth, your weight is 589 newtons. Standing on Mars, your mass stays the same, 60 kilograms, but your weight is 240 newtons. Why? Your mass, the amount of matter you have, stays the same no matter where you are. But because the gravitational force on Earth is greater than that of Mars, your weight is higher on Earth. In everyday life, weight and mass are often used interchangeably because we assume that the gravitational field is fairly constant around Earth. With some precision instruments like analytical balances, calibration for the gravitational field is necessary. To measure mass, you need a balance. There are several types of balances that can be used to measure mass. One type of balance that is used to measure mass is a triple beam balance. To use a triple beam balance, select a balance that has a maximum mass that is greater than the item to be measured. For example, in this video, the maximum massing capacity is 610 grams. Examine the increments of measurement. A triple beam balance can measure in the smallest increments on its bar that measures the lowest mass. In this case, the 10-gram bar measures in tenths of a gram. Ensure that with no items on the balance and all the masses on the beams at 0, the pointer on the balance also reads 0. If it does not read 0, then the balance will need calibration. If the balance reads 0, then it's ready to use. Place the object that you need to mass on the pan. Move the mass on the beam that measures in the greatest increments first. In this case, the central beam measures in increments of 100 grams. Move it to the right until the pointer goes below the 0 value. Then move it back to the left 1 increment. Leave that mass in this position. Then move the mass on the beam that measures in the next greatest increment. Move it to the right until the pointer goes below the 0 value. Then move it back to the left 1 increment. Leave the mass in position. Move the mass on the beam that measures in the smallest increments last. Gently tap it forward until the pointer points at the 0 value. If the pointer goes below 0, tap it backwards until you reach 0. You now have the mass of the object. To read the mass from the triple beam balance, read the value on each beam. In this case, 100 grams, 20 grams, and 3.8 grams. Add these values together to get the mass of the object. In this case, 123.8 grams. The hanging pan balance is another tool to measure mass. It works the same way as the triple beam balance. Again, you move the masses on the beam from highest mass beam to lowest mass beam until you get the balance to rest at 0. As with the triple beam balance, you read the value on each beam and add these values together to get the mass of the object. In this case, 100 grams, 20 grams, 3 grams, and 0.82 grams when added together equals 123.82 grams. An electronic scale can be used to measure weight. Unless it is being used in very unusual circumstances, a scale can convert newtons, the unit of weight, into mass because the force of gravity on an object is fairly constant everywhere on Earth. Different models of electronic scales have different levels of precision, meaning that they measure to differing decimal points. To use the electronic scale, select a scale that has a maximum mass that is greater than the item to be measured and has the desired precision. This scale has a maximum mass of 220 grams and a precision of 0.1 grams, meaning that it can measure to the tenth of a gram. Examine the scale and make sure that the units displayed are grams. Many scales have a variety of units that can be measured, allowing you to select the units desired. If the units displayed are in grams and you are measuring in grams, then you're ready to begin. Press the tare or 0 button on the scale. Wait until your scale reads 0 grams. This ensures that the scale is set to 0. Once the scale reads 0 grams, place your object on the scale in the center of the pan. Read the number displayed. This is your mass. In this case, it is 123.9 grams. After you've completed taking measurements with the balance, turn it off. A spring scale can show measurements in grams like a triple beam balance. However, a spring scale actually measures weight. A spring scale is used when you want to measure the weight of something that can hang from a hook. Examine the increments on the spring scale. This spring scale measures in 2-gram increments. However, this other scale also measures a maximum of 250 grams, but it measures in 10-gram increments. For this demonstration, we will use the scale that measures in 2-gram increments. Ensure that with no items on the scale reads 0. If it does not read 0, then the scale will need calibration. If the scale is calibrated, hang the item to be weighed on the hook of the spring scale. Read the value shown on the spring scale. In this case, the object is 100 grams. Mastering the use of diverse measuring tools like balances, electronic scales, and spring scales empowers accurate and reliable measurements, crucial for scientific endeavors and everyday applications. For more information about OHAUS products at Carolina, see carolina.com/OHAUS.